Vacuum casting is a new technology for producing functional plastic prototypes within a few hours. Vacuum casting is a vital element within the R&D departments of many large companies and rapid prototyping service providers, as well as in research institutes and training centers. The modern development process would be unthinkable without it. A prerequisite for vacuum casting is a perfect master model, which can be made conventionally or by one of the new generative techniques like stereolithography, FDM or LOM. Given that not only the part itself, but also every scratch, every pore, and even a fingerprint will be duplicated by vacuum casting, the surface of this master model must be absolutely perfect and not defective in any way. In a first step, the mold-making process is prepared by determining the separation line and lining it with tape. All openings that could obstruct or even make opening the mold impossible must be closed using colored tape. It's worthwhile investing some time in this activity and working very precisely. To prepare the mold-making process, you will need standard as well as special tools, as for example the MK mold openers or the scalpel. But aids from other areas like meat skewers or medical spatulas can also come in very handy. There are no limits to your imagination here. The casting frame can be made rapidly and inexpensively from melamine-coated chipboards glued together using a hot gun. If the four walls that constitute the casting frame overlap at one side, the boards needn't even be cut to measure, but can be individually adjusted to the required size when building the frame. In a second step, the gates and risers are adjusted. Small and lightweight parts can be suspended at the riser alone, while we recommend a solid 3-point suspension for bigger parts. A 2-millimeter diameter hole is drilled through those parts that are highest during the subsequent casting process so that a steel wire can be fixed here using superglue. The casting frame must be big enough to allow an all-round covering of the master model with a silicone layer of at least 2 to 3 centimeters. To prevent the silicone from running out, the frame is sealed against leaking using hot glue. The prepared master model with gates and risers is suspended inside the casting frame and fixed in the right position, again using hot glue. The frame can also be made of other materials. Duplo children's toy bricks, which can be individually combined with a snap-fit system, have proven very successful because they can be used several times over. For small and radially symmetrical parts, an MK plastic cup can also be made into a casting frame. The necessary amount of silicone, which has been calculated from the mold volume, is weighed in a bucket and 10% hardener is added. It is important to note the time when the silicone and hardener were mixed together, because this is when the pot life of 90 minutes begins. The silicone is mixed for 1 or 2 minutes using a mixing tool in an electric drill. It must be completely degassed, as all remaining gas pockets in the mold will extend under vacuum and thus affect the dimensional stability of the cast. For this reason, the liquid silicone is first pre-degassed inside the vacuum chamber using the sawtooth function. To prevent the silicone in the bucket from overflowing, the sawtooth function is started in the automatic mode, and the maximum extension of the silicone is limited by pushing the Enter button. The subsequent evacuating and flooding is done automatically by the vacuum chamber so that the degassed silicone can be taken out of the chamber after half an hour. Now the silicone is carefully poured into the casting frame from one side. This process can be facilitated by tilting the frame a little bit. Once the frame is completely filled and the master model is covered by a layer of at least 2 centimeters of silicone, the casting frame is put into the vacuum chamber for a second degassing of the silicone. The sawtooth function is not needed for this, and it is usually sufficient to go straight to complete vacuum in order to remove all remaining air pockets. The process must be completed within 90 minutes after mixing the silicone because the pot life is running out and the silicone starts to harden. At room temperature, the silicone becomes hard within 12 to 15 hours. Tempering it at approximately 80 degrees Celsius can reduce this time to 2 hours. As soon as the silicone has hardened and the casting frame has been removed, a shot of compressed air is blown inside the mold through the gate so that the mold comes off the master model evenly. Then the mold is cut open with a scalpel along a wavy line. The blade must always point at the colored tape, while the shaft carries out a wave-like movement that later guarantees the perfect fitting together of the two mold halves. After cutting all around the mold in this wavy movement, the pliers are used to hold the two halves apart, and the last connections between the two halves are cut with a scalpel so that the mold can be opened completely. After the mold has been opened, the master model taken out, and the tape removed, the mold is ready for a first cast. To work professionally, you will not only need the vacuum chamber itself, but also two ovens. One for tempering the resin at approximately 35 degrees Celsius, and the other for tempering the mold and the cast parts at 70 degrees Celsius. For the casting process, the mold is closed either using tape or staples, which are particularly suitable for small molds. The mold is then preheated to 70 degrees Celsius in the oven. There is a great variety of PU two-component casting resins available for part production, which can perfectly imitate virtually all thermoplastic materials like polypropylene, polyethylene, polycarbonate, and ABS. The two components of these PU casting resins must now be weighed and pre-degassed. If necessary, the resins can be colored using the MK color kit. Pre-degassing the resins takes between a few minutes and half an hour, depending on the chosen resin. Preheating the resin to approximately 35 degrees Celsius in the second oven facilitates the degassing process. As soon as the resin is completely degassed, the mold can be taken out of the oven and placed inside the chamber on the mold lift. The chamber is again evacuated, and after 3 minutes, the mixing of the A and B components of the PU resin begins. As the pot life starts at the beginning of this process, the stopwatch inside the chamber is set back to 0 seconds automatically. With some resins, there may occur reactions due to escaping gas after the two components have been mixed together. The resin must therefore be calmed by a shot of pressure, which is effected using the go-to function. After this, the mixture is poured into the mold through the funnel. As soon as it starts flowing out of the risers, the process is stopped by pushing the stop button. The chamber is then completely evacuated and the mold can be taken out. If the mold lift is lowered in time, the remaining resin runs out onto the mold so that the funnel is emptied and can be reused. The cups can also be used several times. Heating cup B to approximately 70 degrees Celsius facilitates the removal of the remaining hardened resin. For a quicker hardening of the resins, the mold can be tempered at approximately 70 degrees Celsius so that the parts can be taken out after 15 to 30 minutes, depending on the respective resin. A shot of pressurized air facilitates the parting of the mold and removal of the part. Kneading and bending the silicone mold assists part removal. Gates, risers and flashing are carefully removed with the scalpel. Depending on the resin, the build of the model, and the existence of undercuts, in between 30 and 100 casts can be made from one single mold. The cast parts are a perfect copy of the master model and fit together like the original does. The finished parts allow for rapid and inexpensive testing of all parameters, as well as design checks with respect to fit, form, and function.